network. I don't know who did the assignments. Who did the assignments? Okay, Emmanuel, welcome. I saw your assignments. Emmanuel, please can you tell us what a network is? Computer network. Emmanuel, are you there? Can you all hear me? Can you?
Yes, coach. I can hear you.
Sorry, yes. Good evening.
Okay, thank you. Emmanuel, please, what is a computer network?
Okay, computer network is a network that connects two devices, maybe your smartphone or your computer, for the purpose of sharing data information.
Okay, that's correct. That's correct. Amo, please, what is computer network? Just a quick recap.
Computer network, as rightly as my other brother said, when two or more devices are connected and they share information across various distances. Yeah.
Okay, that's good. It's when two or more devices are connected to share resources and information across distances. You're very correct. You know, we mentioned that understanding how data travels across a network is very fundamental in protecting system, or maybe managing them or controlling them, or even detecting cyber threats. So it's very important that we understand how computer network works, how computer works. Like we discussed about operating system the other time. You understand all those things, it will help you because you can't even protect what you don't know, right? So all these foundations, all these things you are treating is very necessary that you know them before you venture into bigger things. Your foundation has to be very solid. Also, we talk about types of networking. Please, who can help us with types of networking? Types of network, who can help us? It's an interactive class. This is what we learned last week.
I think a router is one of a type of network.
Okay.
A router, a hub.
Okay. Router and hub, that's devices on a network. Asking about types of network.
Okay. Hello.
Yes, Emmanuel, go on, please.
Okay, we have the local area network, which is the LAN. We have the metropolitan area network. We
Okay.
have the wide area network. I don't know if I'm right.
Okay. One wide area network, you're correct.
Yes,
Local
and
area network.
yes,
Mhm. Personal
local
area
area,
network.
personal area. Okay, yes, personal.
Yes, personal area network. Okay. Do anyone have anything to contribute about the types of network? Am, are you there?
Yes, please. Yes, and I think we have um, the campus area network.
I didn't get that.
Campus area network.
Okay, that one falls under local area network.
Local. Oh, okay.
All under local area, yes. Okay. Devices found. The next one is devices found in a network. I will make mention of the and the router.
And the firewall.
the firewalls. And we mentioned that the hub does not have an intelligence
Yes.
to identify where it should send a message to. Is that correct?
Yes.
Okay. So maybe by the time I go through your assignments, I'll be able to decipher. Okay, so today we are going to look at OSI model. I don't know, have you come across OSI model before? Has any of you come across OSI model before?
For me, no, please. Maybe the name is.
Okay, who else? Who have come across OSI model? Nobody. Okay, so today we're going to look at one of the topic in networking. That's the OSI model. Before we talk about the IP address, maybe the router, the switches, or even the internet, we need to understand how computers communicate, right? We need to understand how they communicate, how do they share information, how are you able to hear me even on this call? How do I send a WhatsApp message from here and then it gets transmitted to you in seconds, right? So we need to understand how these things happen, how devices communicate. Imagine I sent a message from here to when you're in Ghana, send a message to you, and then in seconds it's already there. You've received the message. Did that message disappear from here to Ghana? No, it follows a protocol. There's a systematic way on how it happens, on how there are rules guiding on how this information is being transmitted from here to that place. Can you hear me?
Yes, please.
Okay. So, like I'm saying, I send a message to you. For the conversation to be successful, both of us must follow a certain rule. One person speak and then the other person listen, and we both understand the language. Computer work in that same manner, right? Computers, servers, routers, they exchange information every day. Like every seconds, you are sending information, WhatsApp messages, you're sending mails. You are doing your assignments. You're always browsing and doing a lot of things online. You can even ask yourself, have you asked yourself, how does your email travel from your computer to another person's computer, to another person's devices? How does it travel? How does my WhatsApp message get to you? So the answer lies in a structured communication framework, and that is what we are going to look at now. OSI model. It will explain to us how everything is being transferred, how data is being transferred from one device to the other, right? Okay, from my slide, let me read. OSI model is a theoretical framework created in 1984 by the International Organization for Standardization for Network Communication. Is a framework created in 1984 by International Organization for Standardization for Network Communication. Hope you can see my screen.
Yes, please. Yes, coach.
Okay. The model was created to provide a standard way for different computers and network devices to communicate, regardless of who the manufacturer are or who manufactured them. Before the OSI model, many companies built their own networking system and devices from different manufacturers. They often could not communicate with one another. So to solve this problem, ISO introduced the OSI model, which divides the communication process into 7 distinct layers, with each layer responsible for a specific task. So OSI model is like a guideline. It's like a guideline that is provided or created by International Organization for Standardization on how computers should communicate, how different computers, despite no matter the manufacturer, whether it's iPhone, whether it's Android or anything, different make of phones, different manufacturers are able to communicate. So initially, communicate different because produced by different manufacturers, they're not able to communicate. Like if I'm using Android, I will not be able to communicate with somebody that is using an iPhone, right? So in 1984, this International Organization for Standardization now created a framework to say, oh, regardless of your product, regardless of the manufacturer, you can still communicate with each devices. So they now mapped out a rule, a guideline on how each devices should communicate, or how data should be transferred from one computer to the other. Did you understand? Does it make sense? Okay, so this OSI model is just like a global recipe that is followed by all manufacturers, whether it's Samsung manufacturers, Infinix, iPhone, your tablet, everything, your Apple phone, Apple wristwatch, everything follows this. This is like a global guideline. The company must follow this rule so that your computer, your devices will be able to communicate with another devices. This is to say all of them must follow, all the company or all the company with different devices, they have to follow these rules. That is why I can communicate to you now. Some of us are using iPhone, some of us are using Samsung, some of us are using Redmi and different devices, and they're not produced by the same people, not the same manufacturer. But because they are using this guideline, this global guideline, I can send a message using my Redmi phone. I can send a message to someone using an iPhone, and the person will receive it because they're following a guideline. Does it make sense? Does it make sense? Okay, thank you. So the main reason why this OSI model was created in 1984 basically is for so they'll be able to troubleshooting. If there's any attack, you can be able to dictate, oh, this attack is coming from this particular layer. This attack is coming from this particular layer. You'll be able to, sort it out. So I also want to, if you not just get anything tonight, do not get anything tonight, just have it at the back of your mind that OSI model is like a global recipe or a global guideline that International Organization for Standardization created for network communication. This means there is no segregation. Whether I'm using a MacBook or you're using an iPhone or you're using an Android phone, we can communicate because it's following the same guideline. Okay, so let us just let's check the layers, the 7 layers that are responsible for a specific task. Remember, I said to solve this problem, iOS introduced the OSI model, which divides the communication process into 7 distinct layers, which each layer is responsible for a specific task. Do you have any question here? Do you have any question here?
No, please, no, coach.
Any question? Are you sure there's no question? Okay. I was expecting somebody to ask me what's the meaning of OSI. I was expecting someone to ask what's the meaning of OSI, but I just said OSI model. What is that OSI? It's an abbreviation. OSI means Open System Interconnection. Open System Interconnection Model. Remember, we are talking about how network communicates, how devices communicate. And this is a model reference on how they communicate. So the OSI means Open System Interconnection. Does it make sense to you? Hope you got that. Okay. So let's look at the 7 layers. Remember we said that each layer have a specific task. Sorry. So we're starting from the 7th layer. That's the application layer. We can say it's the user interface. This layer provides network services directly to the user, to the end user. Example, the browser. Please let me know if you can hear me.
Yes, you can
Can you
hear
hear
you,
me? Just give
coach.
me a thumbs. Yes, can you hear me? Okay, okay. So from the assignment I gave us, I asked a question like, if I send a WhatsApp message from here to Ghana, should give me the step by step or the processes on how this message will leave my phone here in Nigeria and then get to someone in Ghana in seconds. Or if I send a mail to you, how did it just disappear from here and appear over there? How did it happen? What is the science? It's like, what is the underground? So everything is in this OSI model. It doesn't just happen, but just that it happens in a twinkle of an eye, like with the speed of light. Everything just happened. I'll just send hello here, and you're receiving it in the next seconds. So have you asked yourself that question? How does it happen? Or have you asked that question? How does it happen? Okay, because as a cybersecurity specialist, analyst, you need to know how these things work. Like you need to know step by step on how it works. In case you encounter any challenge or you want to troubleshoot, find out, you'll be able to find out, which layer is this attack or which layer is this problem coming from. You'll be able to dictate and solve your problem without issues. So this application layer services directly to the end user. For example, when you open your browser, yeah, when you open your browser, so when I say application layer, it's not the browser you're opening on it. Like it's not the browser, it's not the WhatsApp. It's the layer that allows this application to communicate over a network. Like you type a request from the application, you type a request from Chrome now. The application layer will not accept it, right? Pass it to the lower layer for transmission. And then it will not bring back your response to you. Do you understand? If I open my Chrome now and type, what is cybersecurity? The application layer will receive it, right? responds to me through the application layer. That is the one you are interfacing with, user interface. Does it make sense?
Yes, yes, please.
Like maybe when you type like into your browser, they send the request to the application layer. The application layer prepares it, then send it to the lower layer, and then bring back the answer or the response that you demand back to you. Does it make sense? Please just let me know if you understand. It's only Amo that is okay, Chloe, okay. Emmanuel, are you understanding?
Yes, ma'am.
Okay. So what did I say again is the full meaning of OSI? Who can bail us out? What did I say is the full meaning of OSI?
You said open system interconnection and be.
Yes, okay. Open system interconnection. Okay. Okay, Logman, welcome. I can see you. So the next one, so when you now send this message, it will now send it to presentation layer. In this presentation layer, translate data, okay, data format between application and network. It handles encryption, decryption, compression, JPEG, MPEG. This is where formatting is done. When you send this message, so when you send this message from the application layer to lower it to the presentation layer, this is where the formatting is being done. Or you can even, I think they call it also a translator or translator layer, because it ensures that data that's sent by one devices can be correctly maybe understood by the other devices, right? It will just format it, adjust. Does anything need to be adjusted? They will not encrypt it, right? They will encrypt it or decrypt or compress, depending. They'll just arrange it and prepare it in presentation layer. Translate it in the way the other devices will be able to understand, right? Hope you know what is encryption. Do we know what is encryption? Do we know what it means to encrypt a data?
Not really. You can just briefly explain.
Okay, please go on. Emmanuel.
No, I was saying maybe you should just briefly explain to us.
Okay, okay. Okay, encryption is like the process of converting. Maybe if if I send you, if I say hello Emmanuel, right, from my WhatsApp, I'm sending to you. Okay, and then from your WhatsApp, you used to see end-to-end encryption, Abby.
Yes.
You see it. So it's a process of like converting a readable information into an unreadable format. So when I send that message from my phone to you, maybe to just be like gibberish, to just convert it into unreadable format that no other person can understand it until it gets to your phone. When it gets, computer communicates in, what's the language now? Bits and zeros and one, binary, zeros and one, binary. Yeah, I remember. So it will just send it that way. But when it gets to your computer, when it gets to your devices, it will now reformat it in the way that you will understand. That is encryption. So all these things happen in the presentation layer. Remember, the first one is application. You type your message, then it will now send it to the lower one, that is presentation layer. In this presentation layer, they'll be like, oh, this data now, do we need to encrypt it? Right? Do we need to, they'll now format it, adjust it in the way the devices you're sending to be able to handle or accept. If it's picture, they'll now be like, is it going to be in JPEG? Is it in MPEG? Like all those adjustments and everything happens in presentation layer. Sense? Little by little, we will understand. Little by little, we'll understand. I just want to carry everybody along. We've seen the application layer, we've seen the presentation layer. Does it make sense? Are you following? Okay. Okay. Because there's no need to rush if we are not getting it. Please, a minute, please. Okay, sorry, trying to answer somebody. I'm at work. Okay, so the next one is section layer. This layer manages establishments, it establishes, manages, and terminates connection between application. So I want to give an insight. You know, when you open your bank app, maybe you want to withdraw or you want to check your balance. When you open it, you log in. When you put in your password, this session layer has already established a communication, right? And once the app, once you are being verified that you are the legitimate owner, you're the rightful owner, it will maintain the section until you do your transaction, you do your transfer, you know. If you open your bank app and stay for some time idle without doing anything, it will just tell you section expired. So it is this layer. When we send this, as you're talking, we're using WhatsApp message as an example too. When you type in through the application layer, it will now send it to the presentation layer. That one will adjust it. Then it will send it to section layer. This section layer will now establish a connection between the devices and then the receiver. I mean the receiver's devices. Does it make sense? Does it make sense? Nine. Does it make sense? Can you hear me?
Yes, we can hear you loud
Yes,
and
coach.
clear.
It makes sense,
Okay.
please.
If I send a message to Emmanuel, this layer will find out, oh, like where are we supposed to send this message to? In order to establish a connection, there will be a synchronization between two devices to be sure that they can actually communicate. So is this section that handles it? Section layer. When presentation layer now push it down to section layer will be like, okay, where am I supposed to send this? Where are we supposed to send this mail to? Or where are we supposed to send this message to? Right? They'll find out where the device is. They will establish a connection. Once they establish a connection, or there's something like maybe synchronization between these two devices, they will not be like, okay, this device is ready to receive this information. They can actually communicate. Then from there, it will not push it down to the next layer. You know, the way we're taking it one. This thing happen like in the speed of light, like it's very fast, travels in light, right? So, but all these things are the processes. Your messages go through these processes before it gets to you. Does it make sense? Are we understanding? Everybody just quiet.
Oh, coach, I'm sure little by little, some of the terms are new to some of us, honestly. So
Yes.
we will get used to as we study.
Okay. So did you understand from maybe the application that when you type in a message in your Chrome, right? Or you use your Google, that this it will just receive it and then pass it down to presentation layer. Presentation layer will look at, oh, do we need to format this message? Do we need to encrypt it? Do we need to maybe compress it? Is it too much? Do we need to compress it? Once they do their own, they'll now move it down to the next layer. That's the section layer. This section layer, first of all, be like message doesn't go in bulk. It doesn't just go in bulk like 1,000, like 1 million will just go like that. No, the network breaks it into different tiny chunks or different segments, tiny segments or chunks, whichever way you choose to call it, called packets. They send it, they now break it into, and then they give it label. They label it. They give it 1, 2, 3, 4, 5, and then it will now be transferred to the other devices, the other account, to the other person's account. So when it gets there, what I said is very sensitive. Number four there first. Number first, there was last. So when it gets there, the other is to assemble it together. It will assemble it together, like put it together so that it will make sense again before it will now you now receive the alert, or before it will now show that, oh, someone else sent you money. All these processes has gone through. So like when I send you a message, it doesn't just drop over there. The network breaks it into tiny chunks called packets. Packet is just like it's like a digital envelope. Can you hear me? Is it making sense?
Yeah.
Yeah. Yeah, I know it's new to some of us, so just that's why I'm taking time to explain it. So network packet is just like a digital envelope. It carries information, across a network. So when you send a message or open a web app, or maybe you're streaming a video, your data doesn't just go all at once. It's split into small chunks. And this chunk or this tiny segment is what we call tiny unit is what we call packets. So as this packet is going, each packet contain there's a header. This header is information about where this information is coming from and where it's going to. Payload, this is the data that is being transmitted. Can we understand? Hope it's not too much for us to understand.
Yeah, we are catching up little by little.
Amo, please just say it's going. Are you grabbing?
Yeah, we are grabbing. I mean, the terms are much, but we will get there little by little.
Little by little. Okay, Chloe. Okay. Emmanuel, does it make sense?
Kind of, but let's just go through this session first. Then I think we just need to go and go through
Yeah,
it again. Yes,
yeah. If you go through it, and I believe you will understand. That's why I'm just
yes.
taking it, yeah, little by little, little by little. But at least even if you did not get anything, just know that a take home that, oh, when you send a message, that it doesn't just deliver in bulk. It is being broken into segments or into tiny chunks called packets, right? So when it gets to the other recipient devices, it will assemble it will just assemble everything together so that it will understand the information that is being sent. Okay, so we talked about the transport layer, talked about how sorry, we talked about how TCP is very sensitive, and then UDP. Let me just talk briefly on UDP. UDP like is maybe when you are making a video, when you're on a video call with your friend or in a WhatsApp call with your friend, there's a point you will stop hearing the person. You'll be like hello, hello, hello. You will not hear the person again. So in UDP, it's not as sensitive as when you're using TCP protocol. In UDP, all data, even if it didn't deliver, it can still continue from where you stop. Unlike TCP, that oh, if you didn't get, if the whole information didn't get, but it will send that to just send it back and request again. So that is it for transport layer. Then the next one on our list is network layer. It ensures reliable, okay, sorry, handles routing and IP addressing, determine best paths for data across network, create packets. This layer is just checking for the destination, the IP address, where am I supposed to send it to? Is it within my network or is it outside my network? Right? That is the work of a network layer. It's for routing, looking for IP address. How do I send it? What is the best way to deliver this message to the other device? Am I supposed to send it to my network or is it outside my network? Do you understand?
Yes, ma'am.
Okay. Then the next one is data link. Provides node to nodes transfer, uses MAC address for local delivery. Who can tell me what is MAC address? I think I mentioned it in our last class, MAC address. Longman. Longman, are you there?
Yeah, sorry. What did you say?
Please, what is a MAC address?
MAC address. I think media access code or control. Okay, media access control.
Okay, that's correct.
Address.
Yeah, like what is it? Like what's the MAC address? What's the MAC like? How do you describe a MAC address? What's the MAC
Well,
address?
it consists of numbers and alphabets, and it's more or less like should I say identity card? Yes.
Okay.
Seriously, I don't have any
Okay,
idea.
that's fine. Who again can try? Colon, can you try?
I
What's the MAC
honestly
address?
what it is. I'm sorry.
Okay, that's fine. Okay, MAC address, media access control, is like a unique physical address assigned by a manufacturer. Like the manufacturer puts a unique ID address, a unique address on the body of the devices. So in this data link, before it can be able to live, before a data can be able to live or where it's going to, maybe for local delivery, it just like when you have your house address, right? When a dispatch want to deliver something to you, because you have this address, they'll just say, oh, go to this number 2 Thomas Estates, right? And it will just deliver directly to number 2 Thomas Estates. So that is what the MAC address is like. It's used to identify devices on a local area network. So it's just like it's a physical address on a device, you know, by the manufacturer. So just like a physical address, dispatch rider would deliver something straight to your address, your physical address. Okay, the last one. uh, okay. So the last one is a physical layer. This layer is responsible for the physical transmission of raw bits from one device to another over a communication medium. So the physical layer does not understand what the data means. Its job is to send and receive bits using electrical signals, light pulses, or radio waves, right? So this one go through, it transmits from one device to another through a physical medium, such as through the cable, fiber optics, or wireless signals. So does it make sense to you? Does it make sense to you? Ah, the house is cold today because of
Yeah,
OSI
sure.
model. So I just want you to have it at the back of your mind that an iPhone device can communicate with an Android because of the OSI model, because of the guideline, because of the recipe. It's like a global recipe that all manufacturers must follow so that devices can communicate online effectively. And this model was created in 1984 by International Standardization of, sorry, let me get it again. Let me get the introduction. It was created by International Organization for Standardization for Network Communication. So the person using a MacBook will be able to communicate to someone using an Android phone because they are all following these rules, this guideline, this model, right? And also told us that when you send a message, it doesn't just deliver in bulk. It's being broken into tiny chunks called the packets. And your message is traveled through these 7 layers, this 7 OSI model. The application layer, presentation layer, the section layer, the transport layer, the network layer, the data link layer, and the physical layer. Does it make sense to us?
Yes, makes sense.
Okay. Longman, can you tell me what makes sense?
Oh, well, I mean, basically the whole concept of OSI, which
Okay.
is kind of like a guide that explain how information moves through devices, right?
Yeah.
Okay, let me put it this way: a guide that explain how information moves from a device to another through the network.
Okay. Okay. Where's our Claude? Claude, do you have anything to say?
So my takeaway, what I understand, is that when we communicate, whether we're sending WhatsApp messages or emails, the communication doesn't go to its destination in a bulk, as you said. It's actually
Okay.
broken up into tiny pieces. So I think that
Okay.
makes a lot of sense, but I'll get there. We'll get there eventually.
Okay. Okay. Thank you. Thank you. That's amazing. Emmanuel, are you there? That's amazing. Emmanuel, are you
Yes,
there?
I'm here. Yes.
Okay. What's your take home? What's your take home?
Yeah, my take home is just that before now, we when we send messages, we don't understand how these things move, and this particular, let me say, session is a mind opener, right, to how these things travel, and we send messages to somebody elsewhere in another country, and it gets back to us within seconds, and these layers, according to the OSI model that I just explained, has given us a breakdown of how these things work. And at least now we understand how these things work, and that's just it for me.
All right. Thank you. Amo, are you there? Are you able to say anything? Are you able to
Yes,
talk, Amo?
yes, please. I'm still here.
Okay.
I also um learned about OSI, Open System Interconnection.
Okay.
Yes, and I also learned about the 7 layers of OSI model, the application, presentation, and session. Yes, and the rest. So I think it was just the after the layers, the terms that were coming up. That was what kind of um, made me a bit slow today. But at least
Yeah.
I really learned something too. Yeah, I didn't know the OSI. Yeah, thank you.
Okay. Okay. Yeah. I don't even expect you to just because you mentioned earlier that they are new to you. You're just hearing about them today, right? So I didn't even just expect you to maybe grab everything at once. So I also advise you can on your own go and make researches. Remember, I told you what keep you at the top of your game is researches. Go back, check, read again. It will make sense to you. I promise you to make sense to you, right?
Okay, thank you, Coach.
Yeah. Okay. Any other thing?
I have a question.
Okay, please go on.
Is it possible for any of those layer, to be attacked by, hackers?
Okay, so when I mentioned earlier that this the main the main purpose is also for troubleshooting, right? I mentioned it's for who is calling me? Can you hear me? Sorry, I got a call. I mentioned it was for troubleshooting. So when a particular section or maybe having a network issue or there's a delay, maybe if you're a network engineer, right? The first question, or if someone that works smart, the first thing you want to find out which layer is this problem coming from? Where like your